understanding mixed data. So what is mixed data? Let's see. Mixed data is basically if you have a data set where each feature is a different data type. For example, if you look at this toy data set, you have features that are categorical, ordinal and numeric, right? In general, if you actually look at the different data types you can have for your features, real data is those features that you can place on the real line, right? And a subset of that could be like positive, which is only features that are to the right of 0, right? Or an example of positive is like, the box office revenue of a movie. Or you could have integer, which is, only stuff that lies on, the integer parts of the real line. Or you could have positive integers, right? Example is the number of people who attended an event. You can have categorical data, for instance, is this particular image a cat or a dog or a monkey, right? Or an example of categorical data is, you have different categories such as 3 categories here, countries USA or UK or India, right? Categorical data has the property that, you typically cannot put an order to the various categories. For instance, you cannot say like, a cat is less than a dog or a monkey is greater than a dog and so on. Another type of and a particular subset of categorical data is binary data like male or female. You also have ordinal data, which is like, 1 star, 2 star, 3 star, 4 star, 5 star, where there are 5 classes, but there is an order to the classes. Okay, now you have this toy data set and you have these 4 features. What are the challenges working with this data, right? The first thing you can think of is that, like, let's say you want to apply an algorithm such as k-means clustering to this data. You cannot directly do that because one of the steps in your k-means algorithm is to find the centroid of the points in a particular cluster to get the new mean, right? But you cannot really take the mean of these points. Like, how do you average a country or a director, right? That doesn't make sense. So how do you apply, you cannot apply all your machine learning algorithms, some of them, the same way that you would do with real data that you can put, let's say, in a Euclidean space. Right? So you cannot put this data directly in a 4D Euclidean space. So an even basic thing is like, what is the notion of distance between 2 points when you have a data set like this? So for instance, how do I find out whether the first row is closer to the second row or the fourth row? Right? It looks like the first row and the fourth row are similar, but like, how do I formalize that? Right? So these are some challenges working with mixed data. And the most common notion of distance that we use is the Euclidean distance, which is the bird's eye view or the distance as the bird flies. So if we have 2 points P and Q, the Euclidean distance, as you know, is the square root of, Q1 minus P1 square plus Q2 minus P2 square. And you have this assumption that there is something called an origin when you put these 2 points P and Q in the Euclidean 2D plane here. And you also have this notion that, Q1 is to the right of P1, so Q1 is greater than P1 on the x-axis, Q2 is greater than P2 on the y-axis, and so on, right? So, but this doesn't make sense for mixed data because you cannot directly embed the data points in a mixed data set onto this Euclidean plane, right? So how do we apply our all our machine learning techniques for mixed data? And that is something we will see in the next video. So we looked at what mixed data is and some specific data types that you usually encounter when you looked at mixed data. And we will look at techniques to handle mixed data for our machine learning algorithms in the next video. Thank you.